What's up, guys? Mr. Cool Guy here. Today we are going to talk about the real number system. So, first you have your rational, and the other is your irrational. Again, first is rational, and the second is your irrational. Before we move on to this lesson, guys, please practice converting numbers into decimal forms. Again, practice converting numbers to decimal forms. How can you practice converting numbers to decimal forms? Use a calculator. Again, use a calculator. You guys should have been given access to different types of calculators. Back when I taught on campus, we used either TI-84 calculators or TI Nspire calculators. Both calculators are awesome, so I'm just hoping that you guys have access to those calculators. All right, first off, let's talk about irrational first, actually. What are irrational numbers? Irrational numbers are when decimal place values do not stop with no pattern. Again, decimal place values do not stop with no pattern. So, an example I give you is 3.9876205, etc., etc., etc. That is an example of irrational number. If you notice, the place values, decimal place values, do not stop. It is continuous. What if I give you 5/78? How can you show me proof that 5/78 is an irrational number? I'll give you a hint. Use your calculator. Use your calculator. Use your calculator. 5/78, a fraction. So you're dividing 5 divided by 78 will give you 0.064102, etc., etc., etc. Does not stop. Again, decimal values do not stop. It did not stop, and it did not have a pattern. Another example. Let's say pi. Oops, pi. Someone say, yo, cool guy, isn't pi only 3.14? That's fact. But if you actually put it in the calculator, you put in pi is actually 3.14159.265, etc., etc., etc. It did not stop. So again, irrational numbers are numbers with decimal values that do not stop with no pattern. No pattern whatsoever. Okay? All right, next, let's talk about rational numbers. Rational numbers are numbers that stop at a certain place value. Whether it be in a whole number or in a decimal place value, it does not matter as long as it stops. As long as it stops at a certain place value. Examples that I can give you is 5, 8, 7. Okay, whole numbers. It stopped at the ones place. How about 10.5? Is it a rational number? Yes, it is, because it stopped at the 10th place. What if we go past the 10th place? For example, we say 11.25. Still, it is a rational number because it stopped at a certain place value. 6, let's do 0.625. Why am I using 5? It stopped at that place value. Okay? Now, what if I say that 1/2 is also a rational number. Again, please, for you to prove that 1/2 is a rational number or prove any number be rational or irrational is use your calculator. So 1/2. 1/2 in decimal form is 0.5. Another example is square roots of 100. Use your calculator. Square root of 100 is 10. So this is one example of what a rational number is. But there's another type of rational number is when place value, I need you guys to watch this. Watch the details. Place value, decimal place value, does not stop, but has a pattern. What is an example of that kind of number? 7.898989 and continuous. The place value did not stop, but you had a pattern of this 8 9s. So that is rational. Another way to know is, have you guys seen this line on top of the number? What does that mean? That means that number is just continuous. So that means that is 8.5555555. Okay. What if it had a line on top of two decimal values? Instead of just 8.5 like that, you have 9.12 with a line on top of 12. That is what? 9.12, 12, 12, etc. That is a rational. Remember, the difference between rational and irrational when it comes to place values is irrational has no pattern. Oops. Irrational has no pattern, but rational has a pattern. All right. All right, now we have three different types of rational numbers. One, we have integers. Next, we have whole numbers. And last, we have natural numbers. Integers are numbers that are negative numbers, positive numbers, and 0. 0 is included in your integers. So, examples: -3, -2, -1, 0, 1, 2, 3, and so on. All right. Whole numbers. Now, whole numbers are numbers that are 0 and positive numbers. So what are those? 0, 1, 2, 3, 4, 5, and so on. Natural numbers now are numbers that are from 1 and beyond. 1 and beyond. Example: 1, 2, 3, 4, 5, 6, 7, 8. I had to do that. Etc. Oh, that was horrible. Okay. Look at the differences between integers, whole numbers, and natural numbers. Now, one thing that has to be clarified with all these three types of numbers. These numbers do not include fractions and decimals. All right. These numbers do not include fractions and decimals. All right. Y'all got this. So if this helps for you, please like and subscribe. And I'll see you in the next lesson. As always, Mr. Cool Guy, signing off.
1, 2.
Square root of 100 is 10. What in the heck? Now, before we label each one, oh my god.